Volcanic eruptions are among the most powerful forces on Earth. Beautiful and terrifying, eruptions can inflict enormous havoc on people living nearby. Hot ash flows rushing down a volcano, or mud flows racing down valleys, will destroy everything in their path. Falling ash smothers the land and creates chaos by collapsing roofs and turning day into night. The power of an erupting volcano to damage valuable land and our homes cannot be stopped. When an eruption is imminent, people must be moved from the most dangerous areas around a volcano. But before a volcano even threatens to erupt, we can reduce the risk from volcanic hazards by taking 3 basic steps. The first step is to identify areas around a volcano that could be damaged by volcanic activity. These are areas where decisions about land use and evacuations can save lives and property. Second, monitor volcanoes for signs of increased activity. Scientists can provide advance warning for many eruptions. The third step is to make an emergency plan that calls for public action in response to increasing levels of volcanic activity. People must know what to do before an eruption. People from around the world have used these 3 steps to prevent volcano emergencies from becoming disasters. We will examine these steps by taking a look at how people have responded to real volcanic eruptions. First, we'll examine the importance of identifying volcano hazard areas. One of the world's most tragic volcanic disasters took place on the island of Martinique in the Caribbean when this peaceful-looking volcano erupted in 1902. At the time, everyone living below Mount Pelée in the city of St. Pierre took notice when the volcano first started spewing ash and sulfurous gas into the air. Despite these warning signs, no one knew what to expect from the volcano, and neither officials nor residents made plans to leave their city, located only 7 kilometers from the volcano's summit. 2 weeks after the volcano's first warning signs, a sudden, powerful, explosive eruption generated an enormous ash flow, and within minutes, destroyed the city. 29,000 people died. Only 2 survived. The people of St. Pierre died because they didn't know that Mount Pelée had a history of erupting ash flows. Even as the volcano became increasingly active, people stayed in areas that were soon to be destroyed. So how can we know what to expect from a volcano before it erupts? And how can we identify dangerous areas around a volcano? When a volcano erupts frequently, and its activity is familiar to people living nearby, the type and size of its eruptions are widely known, and so are the areas frequently damaged. The written or oral history of local people often contain important reminders of recent volcanic activity. But what happens when there is no living memory of volcanic activity? How then can we determine what kind of eruption is most likely and where the dangerous areas are located? Each layer of rock around a volcano is a record of an eruption that produced a certain kind of activity, an ash flow or mud flow, ashfall, or even a giant landslide. Through detailed study of these rock deposits, geologists can estimate how often a volcano has erupted and determine the types of eruptions that were most common. Geologists can also identify areas that were affected by these past eruptions. Volcano hazard areas become clear when the geologic information is placed on a map. Just how far away from a volcano lava flows or hot ash flows reach can be shown, as well as which bridges or roads could be destroyed by mud flows. A volcano hazard map is critical for planning evacuations of dangerous areas during an emergency. But the map is just as important for planning future development. both close to a volcano and downstream. A hazard map can help planners determine where to build bridges and pipelines, homes, businesses, and community facilities. Today, the people of St. Pierre have a hazard map. They know which areas will be at risk during future eruptions. For example, the brown color shows areas that could be swept by mud flows, and the red color shows areas likely to be damaged by ash flows. Depending on which side of the volcano the vent is located, ash flows will either travel to the northeast or to the southwest toward St. Pierre. A hazard map, though, does not tell us when a volcano is becoming more active or when it might erupt. This brings us to the second step in preventing a volcano disaster: monitoring volcanoes for early warning signs. Nearly all volcanoes give some kind of warning before they erupt. A scientific monitoring program is critical to detect warning signs early enough to reduce volcanic risk. Through volcano monitoring, scientists can detect and measure even small changes at a volcano before it erupts. These changes might include the widening of ground cracks, the rise or fall of the ground and swelling of the volcano, changes in the composition and volume of volcanic gas before an eruption, and most important, a change in the number and types of small earthquakes beneath a volcano. When a volcano begins to show signs of becoming active, volcano monitoring helps scientists estimate whether an eruption is likely, and if so, when, within months or a matter of days. At a few well-monitored volcanoes, scientists can predict eruptions accurately. For example, this computer screen shows an increasing number of earthquakes before an eruption at Mount St. Helens in 1982. This and other monitoring information allowed scientists to pinpoint the onset of an eruption to within days, and then to within hours. Such warning signs are easy to recognize, but scientists can rarely pinpoint the exact time or size of an eruption. Even though a volcano might clearly be building toward an eruption, deciding when to move people out of the way is almost always difficult. The decision to evacuate hazardous areas cannot wait until the last minute. If officials had waited until the last minute during the eruption of Unzen volcano in Japan, hundreds would have died from ash flows. Lava first erupted onto Unzen's summit crater in May 1991 and quickly formed a mound-shaped feature called a lava dome. As the dome grew over the next 5 years, thousands of ash flows swept down the volcano. Most were relatively small, triggered by the sudden collapse of huge blocks of hot lava. But a few ash flows traveled more than 5 kilometers down populated river valleys. Since scientists could not predict the timing of these large flows, officials decided to evacuate large areas that could be destroyed without warning. One of the largest ash flows occurred on June 3, 1991. Even though officials had established a danger zone and evacuated more than 7,000 people, 43 people were killed inside the zone. As the dome grew between 1991 and 1993, scientists identified a nearby river valley that was also being threatened by ash flows. Several times over an 18-month period, officials ordered people to leave their homes. Then, 4 weeks after the last evacuation, a series of large ash flows destroyed the entire valley. Only one person was killed. An even greater tragedy was avoided at Unzen because officials put their emergency plan into action, despite the scientific uncertainty that existed during most of the eruption. This brings us to the third step in preventing a volcano disaster: developing an emergency plan that includes at least 3 activities. People need accurate information about volcanic hazards, especially the types of activity most likely to occur and the location of dangerous areas. Scientists and officials need effective ways to announce warnings, especially if a sudden eruption or mudflow occurs. People need to know what to do and when to do it. Finally, an emergency plan needs to be tested and practiced. Let's look at what happened when a volcano in Papua New Guinea threatened to erupt and people worked to develop and test an emergency plan. The city of Rabaul and its harbor are located in the middle of an enormous volcanic crater. Just before and during World War II, explosive eruptions built this cone along the harbor and caused a series of ash flows, tsunamis, and extremely heavy ashfall. The eruptions killed 500 people. Beginning in 1983, the volcano threatened to erupt again. Scientists monitoring Rabaul's crater detected a dramatic increase in earthquake activity that continued for the next 11 years. Tens of thousands of earthquakes rattled the harbor. Scientists also detected other changes caused by magma moving below. Parts of the bay were pushed up by more than a meter. Even so, no eruption took place. But the volcano's warning signs were enough for the people of Rabaul to put into place the three components of an emergency plan.
I'm a volcanologist, different geophysicist.
People were informed of the hazards they faced if the volcano actually erupted. Scientists and community leaders gave dozens of presentations to describe the effects of different types of eruptions that were likely to occur. Maps of hazardous areas were posted throughout the region. If officials should ever order an evacuation of the red area, people would know how to get to safe areas, and they would know the location of help stations along the way. As a way to announce warnings clearly, the emergency plan defined 4 stages of alert that were determined by the intensity of the volcano's activity. For each stage of alert, the plan identified the type of warning that would be announced to the public and how it would be done. As soon as scientists determined that the volcano's activity had reached a new level, the next stage of alert was to be announced, eventually leading to an evacuation. Finally, everyone practiced evacuating the hazard areas to ensure that people would know where to go, what to bring, and how best to mobilize their community resources in an emergency. Despite all these preparations, no one could foresee how well the plan would work when the real test finally came on September 18, 1994.
The Rabaul Volcanological Observatory has detected a dramatic increase in the activity of the volcano.
On that Sunday morning, 2 large earthquakes were felt around Rabaul. Earthquake activity suddenly increased later in the day, and by late evening, parts of the shoreline began to rise noticeably. Knowing what this activity meant, people throughout the area began moving to the safe areas on their own, even though an official evacuation had not yet been declared. With help from emergency response workers, the spontaneous evacuation of 30,000 people continued through the night and into the early morning. As the last people were leaving the hazardous areas, volcanoes on both sides of the harbor began erupting. While the city was severely damaged by ashfall in the coming weeks, only 3 people died during the evacuation, a tribute to the emergency plan that was prepared and practiced a decade earlier. To appreciate the importance of practicing the plan, let's look at what happened when this Colombian volcano produced a small explosive eruption with tragic results. Capped with an extensive layer of snow and ice, Nevado del Ruiz first came to life in 1984 after a period of quiet lasting more than 100 years. Scientists, officials, and nearby residents all noticed an increase in the volcano's activity, and a few monitoring instruments were installed to keep track of the volcano's behavior. Scientists prepared this hazard map in October 1985. The map identified areas that could be affected by volcanic activity, and it clearly showed, in green, that the greatest hazard to people would be from mud flows. Several towns in river valleys around Ruiz, including Armero, were shown to be in the direct path of mud flows. A few weeks later, on November 13th, a relatively small explosive eruption sent hot ash flows over the volcano's ice cap. Melting snow and ice quickly formed mud flows that raced down river valleys. Within 2 hours, the mud flows killed 23,000 people in Armero and several other towns. The eruption had been announced, and some orders for evacuation were given. But most people did not understand the warnings. They didn't realize mud flows could be deadly and that mud flows were headed their way. So they didn't move to higher ground, only a few hundred meters away. Tragedies like Nevado del Ruiz can be prevented with an emergency plan that includes the 3 critical steps. Inform people of the volcanic hazards they are likely to face. Announce warnings quickly and widely. And practice the plan. Finally, let's look at another volcano, Mount Pinatubo in the Philippines. When Mount Pinatubo became active suddenly in 1991, it severely tested scientists, officials, and people living around the volcano. Pinatubo had been quiet for more than 500 years when it began to send very clear warning signs in April. Scientists quickly determined that the volcano had a history of infrequent but very large explosive eruptions, large enough to impact more than 1 million people. Several plans were made and quickly put into action. Scientists studied the volcanic rock deposits around the volcano and made a map of the hazard areas. Instruments were installed around Pinatubo so scientists could monitor its activity and provide regular updates to officials and the public. Officials developed an emergency plan. A 5-level warning system was adopted, and in case they were needed, evacuations were planned. Both scientists and officials met with thousands of people to inform them of the hazards and to keep them up to date with the volcano's changing activity. These steps helped officials make agonizing and politically difficult decisions. No one wanted to order evacuations too early because of the enormous disruption that would result. And what if the volcano didn't produce a large, dangerous eruption at all? Even with the uncertainty, everyone recognized an evacuation that came too late would be disastrous. By June 14th, officials had ordered the evacuation of more than 80,000 people from their land and homes. The next morning, Mount Pinatubo produced the world's largest eruption in 80 years. Just as the climactic eruption was getting underway, a typhoon swept over the Philippines. Ash and rain fell over the entire region all day and into the night. Without the steps that Philippine officials took to deal with Pinatubo's activity, thousands of people would have died. Instead, fewer than 300 lost their lives as roofs collapsed under the weight of heavy, wet ash. Like many volcanic eruptions, the activity of Mount Pinatubo dramatically changed the landscape. River valleys filled with more than 100 meters of loose ash flow deposits. These deposits created a new hazard for Philippine officials. Years of increased mudflow activity. In the aftermath of so much change to the land, scientists and officials had to once again take the 3 steps identified in this program. Since mudflows were certain to occur for years to come, new hazard maps downstream of the volcano had to be made. Monitoring instruments were re-established, and new emergency plans were developed to deal with the mudflows. Are you and your community ready for a volcanic eruption? Do you know which areas will be dangerous during the next eruption? Do you have an emergency plan? And when faced with scientific uncertainty as to the size and timing of an eruption, are you willing to err on the side of safety and accept the possibility of false alarms? The ultimate test of your emergency preparation is a real eruption. The time to reduce your volcanic risk is now, before your volcano threatens to erupt. And then, when your volcano rumbles back to life, don't hesitate to use your emergency plan.